Okay, so now we do have a DID and the schema for the institution. Now the institution can issue as many credential as it wants. So we will select option number 3. And now we have only one schema because we did make one schema. So we will select this schema. And then we need to input the specific private data of the customer. So let's say that this credential is granted for someone named Hamza with last name Maniata, which is actually your instructor. And let's say that the grade was 95, the educational number is 12345, and the year is 2022. And the faculty is, let's say, computer science. All right, so we just have generated a new credential. And we have option number 4 here to check out the credentials we do have. So number 4. And then we can see that we have this credential right here. So we will select that and see what this credential is about. And then you can see that we have this credential which has the DID identifier, the name, the schema name, the DID index, which was in the acknowledgement message sent by the gateway to the faculty, and the schema index because we used this specific schema. And then we have some private data right here, the name, the grade, stuff like that. And because of that, because we do have private data in the credential, not the schema, then this credential is only saved privately on the local database of the institution, is not saved on chain. So now we have 3 options for these for this specific credential. We can validate it, we can revoke it, or we can just go back. So let's validate it. Let's see if it's valid or not, because when we generated this, we used the private keys of the university, which is the issuer, and the private key of the schema. So it should be much secure, but at the same time, the miners should be able to verify that this credential is valid. So we sent a request to the gateway, which asked one of the miners to verify the request. And then we will refresh just to see if we received a notification. So refresh, and then we have one extra notification here. So if we press number 6, then we can say that we can see that the response to signature validation request and the result is valid right here, right? So if it wasn't valid, it will be automatically deleted from the system because we don't want the institution to hold invalid credentials, and the institution can generate or issue new credentials anytime it's needed. Let's see how this credential was revoked. But before that, we want to notice that all the information, all the data that was sent in the request of the validation was the hash of the credential. The hash itself was not sent to the blockchain. What the institution did is that it hashed the credential and then signed it using the private key of the schema, and then signed it again using the private key of the university, and then send it to the blockchain. The blockchain then decrypted this signature using the public key of the university, and then decrypted it again using the public key of the schema, and then they just compared, the miner just compared this hash, which was requested to be validated or invalidated. They just compared this hash with the hash that was generated after the decryption happened here of the signature. And since both of them were equal, then the response was valid. Otherwise, it will be invalid. Now let's see how or what happens if the institution decides to revoke this credential. So we will go again to option number 4, which is manage. And then we will choose this credential. And then we have option number 2, which is revoke. So we will choose that. And then it just confirms that, makes sure that the administrator wants to really revoke this, because once it's revoked, it will be deleted from the system. So there's no way to retrieve that other than making the credential one more time. So these are the data, and the administrator needs to make sure that this is actually the credential that he or she wants to delete. So let's press yes, and one more time for the confirmation, we are asked to post the title of the credential and enter. And you can see that the request was sent to the blockchain, and the blockchain performed the proof of authority to agree on the validity of this specific block, which is a revoke block. And this revoke block, as you can see, included the public information of the institution only and the hash of the revoked credential. The credential itself was not hashed. The signature of the issuer right here was generated using the public key, the private key of the institution and the private key of the schema. And then the validation that the miner performed is that it decrypted this signature twice, so that, and of course the body right here was encrypted using the signature here. So the signature was encrypted twice, and then if the decrypted result from this signature was equal to this, then that means that this block or this revoke request was actually sent by this issuer. Now the signature right here in the header is the signature of the miner who accepted this block, and this signature was generated using the private key of the miner itself, and other miners sorry for that, approved that yes, this block is valid because it was issued by the original issuer, and this block, including the header and the body, is valid because it was generated by an authorized miner, and this is the signature for it. Yeah, so we have proofs of signature and we have proofs of work, proof of authority, and then accordingly this miner accepted this new valid block. And if we refresh this screen right here and this screen right here, and then just let's review the local chain statistics, and then we have one block for did, one block for schema, and one block for revoke, right? And here it should be the same. So yes, 111, then we are good. And I guess we should expect a notification here that the revoke block was accepted. So we will refresh here. And yes, we have one new notification. So you can see here that the revoke block, including these public data, these private data. So what happened is the following. The institution kept on a temporary list the requests to revoke, because if the administrator of the institution or the issuer component wants to delete this or wants to revoke it, then this credential will remain in this institution local database until an acknowledgement of revocation was sent by the gateway. So the thing is, the private data and the whole credential was saved temporarily locally right here, and only the hash was sent to the miners. And once the acknowledgement that this credential was indeed revoked, then it shows in the notification here the exact credential that was revoked, so that if it was by mistake revoked, the administrator can actually copy and paste everything right here and make a new credential super swiftly, and revoke the credential that it was initially intended to be revoked. All right, so, and the result, we can see that it's true. That means that the result obtained from the blockchain is that, yes, this credential was indeed revoked. I'm going to refresh again this screen and all the other screens, and you can notice that meanwhile all of this happening through the gateway, and the gateway is not showing any information for the administrator. Everything is happening in the back end of the gateway, and the only information presented to the administrator of the gateway is the statistics of the network itself. So if we refresh this, then we can see that we still have 2 active miners. We're good, and the gateway is pinging the miners every 5 seconds. Of course, this is modifiable, but this is the default setting. And then we have no review mining. We don't have mining requests to consider.